Welcome to the Light Source Materials tutorial for KeyShot 4. This video will demonstrate how easy it is to use KeyShot's light source material types as physical lights to enhance your scene. You may already be familiar with KeyShot's emissive material, which can be used to represent low-cast lights such as LEDs. Or, in this case, with a gradient opacity map applied to create a sharp reflection across a display. The emissive material is great for these purposes, but in this tutorial, I'll show you how to use point and area lights to actually project light from objects in your scene, such as architectural lighting and automotive headlamps. There are three types of light source materials in KeyShot 4, which can be applied to any imported geometry. To apply these materials to your part, drag and drop from KeyShot's predefined selection of lights in the material library, or simply edit the material and select the type from the drop-down menu. To see the effect, I will reduce the environment brightness and enable ground illumination in the Settings tab. Another option would be to add a ground plane under the Edit menu, which produces more subtle results. In general, the point light diffuse material is used to represent strong, concentrated light sources that cast a hard shadow, while area light diffuse is used to represent evenly distributed, scattered light, producing a soft shadow. Point IES lights use IES profiles to accurately replicate the behavior of real-world lighting products. Depending on your scene, you may want to apply these materials directly to an existing part in your model, such as a filament in a light bulb, or you may want to apply these materials to an imported piece of primitive geometry like a plane or sphere like you see here. Keep in mind that less complex geometry will produce more controlled and consistent light. So let's jump into a scene and set up some headlamps using the point and area diffuse lights. What you see here is the final result, so let me show you how I achieved it. Originally, this model only contained the headlamp housing. So I quickly modeled a broken torus shape and convex lens and positioned them in place using the Move tool. The next step is to add a material to the lens. In this case, I'll use thin film for an added touch of color. Next, I'll duplicate the lens, move it forward slightly, and change the material type to point light diffuse. The point light diffuse material will project light from the selected geometry's centermost point. The geometry itself will no longer be visible, but will be represented by a small orange dot. The point light diffuse material produces a cast light that is most intense in the center and falls off with distance. This type of light source material is best for creating hard shadows and representing stronger, more concentrated types of lighting, such as car headlamps or flashlights. The hardness of the shadow can be adjusted by using the radius slider, while the power of the light can be adjusted by watt or lumens. For these values to be accurate, it's important that your model units are correctly identified under the Edit menu. Remember, you can always type in a value larger than the slider allows. For further accuracy, color can be specified by Kelvin to represent real-world lighting. We have also included some common default values in the color library that can be drag and dropped onto the material's color swatch. Now let's unhide the torus and change the material to an area light diffuse. This material type produces a soft cast of evenly scattered light and will have a consistent spread across the part it is applied to. Area light diffuse can be used like the emissive material to create a glowing effect for products such as illuminated device displays and heat coils, or to simply provide illumination in areas where the HDR doesn't penetrate. By default, this material is visible, but under the advanced settings you will find the ability to control this. Also found here is the sample slider, where you can improve the quality of the projected light, but be mindful that increasing this will also add to render time. Now that we have these set up, let's duplicate the 3 parts, move, and scale to fit the smaller light housing. Finally, I'll duplicate the lens one more time, change the material to an area light diffuse, and move it back so it's not Z-fighting with the thin film. For the finishing touch, we'll add a bloom effect to accentuate the glow. In addition, we can enable focused caustics to produce a scattering of reflected and refracted light around the housing. So now that I've shown you how to use point and area diffuse lights to enhance your headlights, let's go back to our lamp scene and talk about the point light IES material, which is used to accurately represent the behavior of real lighting products in interior and architectural scenes. Like the headlights, this model does not contain a lens or bulb to apply our light materials to, so I've imported a planar disc, which I've positioned under each lamp. If we edit this material, we can assign an IES profile. IES light profiles contain photometric data of real-world lighting and are widely used and distributed by lighting manufacturers. For example, here is a page of free IES downloads of the complete line of Philips products. Like the point light diffuse, the point light IES projects light from the object's centermost point with the geometry no longer visible. However, you can now see the orange wireframe of the selected IES profile. The visibility of the wireframes can be toggled by pressing the hotkey L. The direction of the projected light is on the individual part's negative y-axis. This means that you must rotate the part to change the direction of the light. So if you're applying this type of material to an existing piece of geometry, you may want to apply it to a duplicate of the original part, or an imported primitive so you can make position adjustments without making changes to your original import. Finally, there are a couple things to keep in mind regarding the quality of your renderings. For the best quality and fastest output, try to keep the number of individual lights in your scene to a minimum. Also, if your scene contains rough or textured materials, you may want to increase the individual material samples. You can also increase the samples of the entire scene in the advanced control output settings, or simply render using the maximum samples mode. In conclusion, using KeyShot 4's new light source materials is an easy way to enhance the lighting and visual appeal in your scene. These materials can be used individually or in layered combinations to create robust visual effects in your 3D renderings.